Hi, hello everybody. Good morning, good afternoon, and good evening. My name is Pasumita Krishnamurthy. Today I will be doing a presentation on the subject computer architecture, and the topic will be instruction sets. So this slide was prepared by my team members and I. However, I will be the presenter to bring you throughout this entire presentation. And I would like to mention my team members who are Muhammad Arifin, Sharwin Nair, and as well as Ariban. So moving on to the presentation. Firstly, let's look into the contents, which are a glimpse of what you will be encountering throughout this entire presentation. So firstly, we'll look into the infix expression, which were made by my team members and I together. And then we'll look into how we would do a program execution using a stack diagram. And thirdly, we would look into the conversion from infix to postfix notation. So this is the infix expression that my team member and I have made. Our goal is to solve the conversion from infix into getting this answer as our postfix expression. So before we move into the conversion from infix to postfix, I'd like to show you guys how we would do the program execution using a stack diagram. As you can look onto your left hand side, there is both instructions and also a written solution. A written solution is basically solving the infix expression without using a stack diagram, and it is to ensure that when you do your stack diagram, you will be getting the right answers, so you can look back into your written solutions. Sometimes it might be easier for you to just take the written solution answers and include it into your stack diagram. So this instructions is from the zero address of the question that we've made. And we have divided our stack diagram into three parts. So firstly, we divided the expression into two sub-expressions, which was first sub-expression and into second sub-expression. So the reason we did this is to avoid complications and getting confused when you are solving part by part of the expression, because as you've seen before, our expression was pretty long, so we had to divide it and split it into two sub-expressions. And then from then onwards, we just follow the instruction. When it says push B, first is B. Okay, so it's B, and first is B, and then we have push C with push C and B, then push D, then bottom. The bottom part remains the same, which will be push B, C, and D. As you are adding into more of the instructions, you have to put the new ones on top of the old ones. And then we have push C, push D, push push B, push C, push D, and then multiplication. And then once you've reached a operation which is multiplication, you start doing the question. Like for example, C, you multiply by D, and then you just do it one by one, following each of the instructions and adding them into the stack diagram right here. Finally, once you've got both of the answers respectively from the first sub-expression and also the second sub-expression, you're going to combine both of them like so, and then multiply it. The reason why we multiply is because that's how the question that we have given has said, that we have to multiply both of the sub-expressions. Now let's look into how we're going to do a conversion from infix to postfix. So this is the given expression, which is the question that we have made. But before we solve the expression from infix to postfix, I'd like to mention about certain rules, simply which are BODMAS and also PEDMAS, which are how to solve the expression step by step. For example, first we are going to solve the expressions inside the brackets. And if you have a question asking, oh, there are so many brackets, meaning there are brackets in brackets or parentheses in brackets, so which one should we solve first? We'll look into the solutions later on which one we'll be solving first. Or as it mentioned here, we would solve the operations inside the parentheses first or brackets. Secondly, we move on to exponents. However, if you look into our given expression, we don't have any exponents such as powers or roots. It's just simply basic calculation operations, which include like addition, multiplication, division, and subtraction. So we can skip the second part. If you don't have any powers and roots, just immediately move on to the ones with multiplication and division. And always remember to perform your operations from left to right. So once you've completed the multiplication and division, we will finally, the left bits will be addition and also subtractions. Now let's look into the solutions for this expression. Firstly, we would want to evaluate the innermost parentheses or the ones innermost inside the brackets, such as b minus c multiplied by d, which is right here, as you can see. And your answer when writing into postfix notations, all the operands will be on the one side and all the operations will be on the other side. And then next, once you've solved the innermost parenthesis, we'll move on to outer parenthesis. So an example right here is f multiplied by g minus h, which is inside the parenthesis. And if you go back to the given expression, you can see the f is still inside a parenthesis. However, it is in the outermost parenthesis, and g minus h are inside the parenthesis. Thirdly, we would evaluate the right side expressions because from A to H is before the multiplication, which would be the left side, and from I to O, it will be the right side of the expression. And as I've mentioned previously in the rule, you have to solve the given expression from your left hand side to the right hand side. So, and also it's the same method that we've used for our stack diagram, where we have split into two sub-expressions. One is before the multiplication and another one is after the multiplication. Then we would solve both sides respectively, and then once we get the final answers from both parts, we would combine them and multiply in this case. In other questions, you might encounter two sub-expressions, and in the middle of two sub-expressions, there will be either addition, division, subtraction, or multiplication in this case. And once you've completed all of these calculations, all of the solutions, your final postfix notation would look like this. Yeah. So as here, this would be your final answers. And as I've mentioned earlier, all of the operands will be on one side and all of the operations will be on the other side. Here, you might question why is it written in such way. It's really simple for you to actually understand or get the expression from the final postfix notation. It simply is as A, you have plus, so here's A plus, and then B minus C, so B minus C, and then there's a multiplication, and then D. It's almost like expanding the brackets when we are performing in algebraic expression. That's the reason why we write all the operands on one side and the operations on the other. As for from E to H, let's see, E you plus with F and then multiply by G, subtract by H, and then this entire part will be divided by I minus by j multiplied by k. And then here we have the L, which is added, and then M, which is multiplied by N, and then divided by N, and then O, which is multiplied by N. And then finally, we would have to write the multiplication in the middle of two sub-expressions at the very end, like this. So that's it for the presentation. Thank you very much for watching. I hope you learned how to solve from in the conversion from infix to postfix, as well as how to execute the program for using a stack diagram. Thank you. Bye.